In this video, we'll be looking at another integration by substitution problem involving definite integrals. The example that we'll be doing is the integral from 0 to square root of pi of x times the sine of x squared dx. Our first step is to choose a value for u in terms of x. So we will choose our argument of the sine function to be our u. So u equals x squared. Then we want to take the derivative of u with respect to x, and we get du is equal to 2x dx, but our problem has a factor of x and a factor dx, so we need to divide both sides here by 2 to get x dx is equal to 1/2 du. Then we need to make substitutions so that the expression is all in terms of u. Our limits of integration are from 0 to square root of pi, so we need that in terms of u. If we put 0 into our equation, u equals x squared, we have u equals 0. So that will be our lower limit of integration. And then if we put square root of pi in, we have u equal pi. That'll be our upper limit of integration. So our expression then in u is the definite integral from 0 to pi of sine u times 1/2 du. Now we can pull the 1/2 out in front, and then we're ready to integrate. This is our 1/2 from in front. The integral of sine is a negative cosine, and we're evaluating from 0 to pi. So the fundamental theorem of calculus says to evaluate this expression with the upper limit, and then subtract from that the expression with the lower limit subbed in. So we have 1/2 times negative cosine pi minus a negative cosine 0. Cosine of pi we know is a negative 1, so we have negative 1. And then cosine 0 we know is 1, and these two minuses become a plus. So I have 1/2 of 2, which we know is 1. Now let's look at this expression integrated on the calculator. Want x sine of x squared. We want our mode in radians. And we want a zoom trig. And we want to evaluate the integral, which is choice number 7, from 0 is my lower limit, and my upper limit is square root of pi. Square root of pi. And we get 1.